Welcome to G Fun Facts Online. A quiet revolution is humming beneath the surface of our modern world. It's not powered by politics, but by ions. Not by speeches, but by electrochemistry. We are in the middle of a great leap in battery technology, and it's about to change everything. For decades, the lithium-ion battery has been the champion, powering our phones, laptops, and now our cars. But as our world demands more energy and a cleaner future, the limits of this technology are showing. The race is on to find what's next, and the results are incredible. We're talking about a fundamental shift in how we store and use energy, so let's dive into the future of power. Before we explore the wild frontier of new batteries, let's be clear. The reigning monarch, lithium-ion, isn't going anywhere just yet. In fact, it's getting some serious upgrades. One of the most exciting is happening in the anode, the part of the battery that stores lithium ions when you charge it. For years, we've used graphite, but it's hitting its limits. The new contender is silicon, the second most abundant element on Earth. Silicon can hold 10 times more lithium ions than graphite. For an electric car, this could mean jumping from a 310-mile range to over 540 miles on a single charge. That's range anxiety completely gone. But silicon has a big problem. When it absorbs lithium, it swells to over 3 times its original size. This constant expanding and contracting can crack the anode and kill the battery quickly. Scientists are getting clever though. They're creating silicon graphite mixes, engineering tiny porous silicon structures, and even using wonder materials like graphene to coat the silicon and hold it together. Companies like Amprius Technologies are already using this tech in things like high-altitude drones. Now let's look at the other side of the battery, the cathode. Here, another innovation promises a million-mile battery. Traditional cathodes are made of tiny crystal clusters that crack apart over time, which is why your phone battery gets worse every year. The solution is the single crystal cathode. Each particle is one single, solid crystal, making it incredibly resistant to the stress of charging and discharging. The results are astounding. Researchers funded by Tesla have shown that batteries with these cathodes can survive 20,000 charging cycles. That's equivalent to an EV driving about 5 million miles. Imagine a battery that outlasts the car it's in. These ultra-durable batteries could then be used for a second life to store energy for the power grid. Big players like LG Chem are already racing to mass-produce them. So while lithium-ion is getting a major facelift, a whole new wave of battery chemistries is coming, and they are true game-changers. Perhaps the most hyped of all is the solid-state battery, often called the holy grail of energy storage. The key difference is right in the name. It replaces the flammable liquid electrolyte in current batteries with a solid material, like a ceramic or polymer. This simple change has massive benefits. First, it's much safer. No flammable liquid means almost no risk of fires. Second, the solid barrier stops the growth of dendrites, tiny metal spikes that can cause short circuits. This allows for the use of a pure lithium metal anode, which has a much higher energy capacity than graphite. A solid-state battery could potentially double the energy density of what we have today. That means an electric car with a range of over 1,000 kilometers or 600 miles on a single charge. They also promise faster charging and better performance in extreme temperatures. The road to making them is tough. It's hard to get ions to move efficiently through a solid, and manufacturing is still complex and expensive. But the race is on. Toyota, Volkswagen, QuantumScape, and Solid Power are pouring billions into this tech. We expect to see them in high-end EVs between 2027 and 2030. While solid-state gets the headlines, another contender is quietly gaining ground. The sodium-ion battery. These work just like lithium-ion batteries, but they use sodium ions instead of lithium. The biggest advantage? Sodium is everywhere. It's the 6th most abundant element and can be pulled from seawater. This makes sodium-ion batteries potentially much cheaper and more sustainable than their lithium-based cousins. They're also safer, less prone to fires, and can be fully discharged to 0 volts, making them easier to transport. Their main drawback is lower energy density because sodium ions are bigger and heavier than lithium ions, so you won't see them in a high-performance sports car anytime soon. But they are perfect for applications where cost matters more than weight, like storing energy for the power grid, or in smaller e-bikes and city cars. CATL, the world's biggest battery maker, has already started putting sodium-ion batteries into vehicles. Next up, for applications where weight is everything, we have the lithium-sulfur battery. This is the lightweight heavyweight of the battery world. It pairs a lithium metal anode with a sulfur cathode, a combination that has a theoretical energy density up to 5 times higher than current batteries. This makes them ideal for electric aircraft, drones, and satellites, where every gram is critical, and sulfur is cheap and abundant. The main hurdle has been something called the polysulfide shuttle effect, where parts of the sulfur cathode dissolve into the electrolyte, causing the battery to degrade quickly. But researchers are making progress, using materials like 3D graphene to trap these polysulfides and extend the battery's life. Expect to see lithium-sulfur batteries first in specialized aerospace applications around 2025 to 2027. Finally, let's talk about graphene. You've probably heard of this wonder material. It's a single layer of carbon atoms that is incredibly strong, light, and conductive. In batteries, graphene isn't a new chemistry itself, but a powerful enabler. Adding a little bit of graphene to an electrode can dramatically speed up charging and increase energy capacity. Its strength can help stabilize materials like silicon, preventing them from cracking. In lithium-sulfur batteries, it can be used to trap those pesky polysulfides. The main challenge has been the high cost of producing high-quality graphene, but as prices fall, this material will play a huge role in boosting the performance of nearly every type of battery we've discussed. So what does this all mean for our world? The impact will be massive. In the car industry, it means EVs with 600-mile ranges that can charge in 15 minutes, all at a lower cost. This will be the final nail in the coffin for the internal combustion engine. For our energy grid, it's a game changer. Technologies like sodium-ion batteries are perfect for storing huge amounts of energy from solar and wind farms. This solves the problem of intermittency, when the sun isn't shining or the wind isn't blowing, making a fully renewable grid possible. And for our personal gadgets, it means smartphones that last for days, laptops that run all day without a plug, and medical implants that last for years. But this bright, battery-powered future comes with a sustainability challenge. The current demand for lithium, cobalt, and nickel is creating geopolitical tension and environmental concerns. Cobalt mining, in particular, is linked to serious human rights issues. New chemistries like sodium-ion and lithium-sulfur help by using more abundant and ethical materials. But the most critical piece of the puzzle is recycling. We can't just throw away billions of batteries. We need to build a robust circular economy where we efficiently recover and reuse the valuable materials inside old batteries. This will reduce waste, cut down on mining, and secure our supply chains. The great leap in battery technology is about so much more than just science. It's about forging a cleaner, more sustainable future for our planet. The road ahead requires massive investment and innovation, but the destination is clear: a world powered by a new generation of safe, powerful, and long-lasting energy storage. The quiet hum of the battery revolution is getting louder, and it's heralding a brighter future for us all. Thanks for tuning in to G Fun Facts Online.